Hi, hope you guys are doing well. Nowadays, we can buy electronic device for a couple of bucks. Or if you want to do it yourself, you may just grab an Arduino, Raspberry Pi, or any other development board. Then, you write a couple of code lines and voila, you got yourself a running project. I do like Arduinos, Raspberry Pis, and its models. I've got myself plenty of them, but nothing will change the pleasure of achieving a goal using your own knowledge and some electronic components. In this video, I'd like to show you how to have fun while learning electronics. We will design and put together a really cool LED blinker, which can even be a game to play with your friends. So, let's get started. Well, I don't even know how we can call this game, but it's gonna be a kind of luck game. Let me explain you. We are going to place in a breadboard 10 rows of LEDs and gonna give them values. In my example here, I'm giving them values from 100 to 1000. So 1000 is the highest value. With the help of this push button, the rows will light up in sequence and the speed will decrease, and after some time it will stop in one of those rows. It will work randomly. That means we never know where it's gonna stop. The first step is to place some LEDs in each row. And the next step is figure out how we're gonna drive the LEDs to light up in sequence and work randomly. First, let me put the LEDs on the breadboard and then we can discuss how we are gonna drive them. I will be using this breadboard. It's the perfect size for our need. It's 5.5 centimeters wide and the length is 16.5 centimeters. We also need some LEDs. I will be using this kit that I will put the link in the description down below. It contains 10 different colors of LEDs. We also need some jump wires, different colors and size. And some LED resistors. I could use just one resistor for the LEDs, but different colors of LEDs draw different amount of current. To have the same brightness, I'm probably gonna have different values of LEDs for each row. So let's finally place the LEDs on the breadboard. We can use the numbers on the breadboard as a reference for our rows. So I'll be placing the anode of the LEDs in the rows with numbers and the cathode in the subsequent row. I will do the same for all the other rows. Note, in the middle of the breadboard we have this gap. That means one side of the breadboard is not electrically connected to the other one. So we have to place some jump wires connecting anode and cathode from one side to the other side. For the next rows, I will be hooking up the jump wires before placing the LEDs. It's gonna be easier. We now have to repeat this procedure through the 9 other rows. Now we have all the jumps in place. We have to hook up all the LEDs. So here is our board with all the LEDs in place. To test it out, let's place some jump wires between the anode of the LEDs to the positive rail of the breadboard, and after we're gonna place some resistors between the cathode and the negative rail of the breadboard. As I mentioned before, different colors of LEDs can draw different amount of current. So I'll be using 100 ohms resistor for most of those rows, but the brightest ones we can place different resistor to get the same brightness. We will be using 5 volts as a power supply. Now let's power it up and see if everything works fine. We have got everything lighted up, but this green row is too bright, so I used 220 ohms resistor for the blue row on top, and then I'm gonna replace these 100 ohms for 220 ohms as well. still quite bright, but it's a bit better now. Now we have to find a way to drive the LEDs. That's the datasheet for a good option for our need. It's a CD4017B and it is a decade counter. So that means it has 10 decoded outputs. So the first, it's our outputs, and the first output, it's marked as 0, is the pin number 3. The second output is the pin number 2, and so on and so forth. So now let's see the nature of those outputs. So as you guys can see here, the first output finishes here, that's a high signal, and when this first output finishes, it starts the second one. When you finish the second one, you start the next one, and so on and so forth. We still have to talk about the clock, but it will be a subject for the next step. So here is our counter, CD4017B, and it has 16 pins. 10 of them are the outputs. We're gonna use those 10 outputs to drive the 10 rows we have in our game. As I said, it's quite cheap option. Let's have a look on eBay. I bought 10 of them for 99 cents, free shipping. Here you can see the seller is Satisfy Electronics and the price is 99 cents. That means less than 10 cents per unit. Now I'm gonna place the IC in another breadboard, and according to the datasheet, that's the wiring schematic we have to follow. It is quite simple. The pin 16 goes to VCC, and the pins 15, 13 and 8 go to our reference ground. Then we connect our output pins, we have 10 of them, to the anode of each LED row. So let's do that. Here I have everything wired up according to the schematic. So let's go ahead and hook up one more jump wire in the pin 14, that's our clock pin. We still have to figure out a way to give a clock signal to this IC, but for a while we can hook up this pin to the negative rail of our breadboard, and in this way we're gonna check if everything's working fine so far. In order to get power in the second breadboard, let's place some jump wires between those two breadboards, negative rail to negative rail and positive rail to positive rail. Now let's power it up. It's blinking in sequence, and if you hook up the jump wire, the clock pin, to the ground, it should stop as soon as we place the jump wire in there. At this point we could maybe put a push button connected to the clock pin, but it would stop the LEDs straight away, and that's not what we want. Actually, the function we need for our push button is to start this process. I mean, the LED is blinking, and the signal that goes to the clock pin of the IC will decrease the speed, and it will stop in one of those rows after some time. Wow, I just got 1000 points. But let me stop play and let's see how we can send a clock signal to this circuit. When you talk about clock signal, the first thing that comes in mind is a 555 timer, and that's what we're going to use. So here's the circuit I came up with. In a previous video about servo testers, I showed you how to calculate the values of the components for a 555 timer circuit. So I'm gonna link the video in the description down below. For a while, just let's put together this circuit. You guys can change the values and see how it changed the behavior of our game. It's important to remember the output pin of the 555 timer should be connected to the pin 14 of the CD4017B. We are done, so let's test it out. It's working exactly how we planned. Now it's time for a quick game. You guys against me. I prepared this small table and you're gonna have 5 rounds, and here in this table you can write down the values. As you guys are my guests, I let you start. So let's begin. It's your turn. Yes, I know that I have to press the button for you guys. First round, you guys got 200 points. It's now my turn. And yes, I got 100 points lead in the scoreboard. It's your turn again. Now you guys rocked. 600 points. It's my turn. Oh no, I got 200 points. You guys are leading. Your turn again. That's impressive. 900 points for you guys. So it's my turn again. And I got 200 points once again. Oh no. That's your turn. Wow, 800 points. I can't catch you guys anymore. Well, my turn, and I hope I don't get 200 points again. Well, 400 points. It's a reasonable score. So that's the last round for you guys. That's impressive. 900 points again. So I have no chance, but I go for the last turn. And of course, I got 200 points once again. So the sum gives you guys a total of 3,400, and for me 1,300. You guys won. So I guess that's it. It was a simple and quick project, but we could learn a bit of electronics and have some fun. Really hope you guys like the video. If yes, please thumbs up, subscribe, and I will catch you next time.